And so here we have a coil with an inductance of 2 millihenries, so 0.002 henries. The current through it changes from 2 amps, from 0.2 amps to 1.5 amps in a time of 0.2 seconds. So delta T 0.2 seconds, and delta I, if we go with I1 minus I2 like we've been told, then we have an increasing current 0.2 amps minus 0.15 amps, however, tells us that delta I rather is equal to negative 1.3 amps. Now, think about the polarity, because it's in increasing current, but if we're told to go with I1 minus I2, it comes up with a negative value for that, right? Okay, so remember now that we're asked to calculate V induced, and for the inductor then, V induced is equal to the inductance value times the rate of change of current. And so we have the inductance of 2 millihenries, or 0.002 henries. And we multiply that by the average rate of change in current, and we got negative 1.3 amps, and divided by 0.2, and that's seconds there, not a 5, that's the unit, right? Okay, so V induced then, if you do the math, it has a negative value, and it is 0.013 volts, and so we should therefore say that V induced is equal to negative 13 millivolts. Now, and so here, the idea that voltage is negative is because it opposes the source voltage that created it, and the current is rising. And so it asks us to indicate on a sketch the direction of induced voltage. And so what I did then was I pulled in a sketch from the notes in the workbook, and it's this one. And so I'm going to bring that over now onto this page here. I hope I am. And I'm going to pop that in there. Okay, now remember then that the current is increasing, and that's what we said it was here, right? So the current is increasing. So V induced got this value here, and the 13 millivolts then, remember the polarity negative says that this polarity here is opposite to the polarity of the source that created it. And so that's where your the idea of it being negative comes in, right?